If this cubical unit cell consists of 8 small cubes like this, each containing a regular tetrahedron in it, whose diagonal is here, it will result in that famous duotete cube or Davidoff star, and it looks like this. Like that, and I attached one cube in here to see there is a tetrahedron. So this is a duotete cube, and it's composed of 14 spheres. This is called face-centered cubic lattice, and it has 14 spheres. Or we can have the 12 around 1 or a nucleated cube. But I want to show that, folks, this has 14 spheres, this has 13 spheres altogether. But if we fuse them together like such, it's one and the same. It's the same old thing. There is no conversions, there is no different strategies, no different modules. It's one and the same. It depends where one dissect. Like you see this one in here, that would be 12 around 1. This one on the edge would be 14 spheres. And so on and so forth. We can flip it and see the same things. So in either case, these are closed cubic packing. It also includes the hexagonal closed cubic packing, which has the same sphere density as that nucleated cube, 12 plus 1. This is 12 plus 1. And also, I have little markers here. Also, these can be fused together. Let me find out how. Now I'm coming in problems in here. Oh, okay, it's like this. So we can fuse them together like that, and it's again, they go together, and they are closed cubic packing. So all these matrices exist, they are all made of the same building blocks. Even though synergetics teaches this different variation and different aspect of these identical spheres, it's all one and the same. It's a regular tet and a regular octahedron. But we also can duplicate this by irregular blocks. So of course, this is a regular blocks, it's a tetrahedron, a regular tetrahedron, and a quarter octahedron. So if a regular tetrahedron is our volume unit, then a quarter tetrahedron, a quarter octahedron going to be same volume, that's like this, same volume. And we can do this also with irregular blocks. So we have 2 tetrahedrons in here, made of 3 solid kites, fused like that. So we have a tetrahedron, a regular tetrahedron, and an octant already fused together like that. And we're going to add, of course, these octahedra blocks, octants. Oops. Let me remove this one. We replace it with this one. And we have the famous 60-degree coordinate system. This is a tremendous breakthrough in modeling. In either case, it depends when one chooses to dissect. So this is the octatras, the 60-degree coordinate system, and it's same. This is still not comprehended by the so-called synergio teachers, just mind-boggling. Fascinating how Fuller cult manages to brainwash handful of so-called experts. These demos always result in argument among the shittergetics experts. It is the most hilarious smart site in all of the internet. It just shows how shallow the knowledge they're trying to promote actually is. So, since we show that with the regular blocks and irregular blocks arriving at the same outcome, this relation is self-evident at the first order magnitude or 1/3 of the cube, which is this regular tetrahedron, or 1/6 of the cube, which are blocks that are half the size of the regular tetrahedron. In either case, we're modeling the same thing, same consistency, and any level or magnitude. No need for elaborate conversions, imaginary cubes, nor abstract strategy. Simplicity is always a key to better solution, especially when teaching. Do more with less approach is totally absent in synergetics and its modeling, computation, or sphere packing. One frequency synergetics cube equals 72 modules. In my system, one frequency cube, which is this one, this small cube here, consists of 6 modules, a tremendous efficiency difference, still not comprehended by any synergy enthusiast, just hilarious.